Hello, ladies and gentlemen. It's Matthew Farrow here. Welcome back to my space. Yes, this is the first of the videos in this playlist where I actually start solving the questions without using the L'Hopital's rule. So the first question on this problem set is number 1, which is the limit of 1 minus cos pi x over x squared as x tends to 0. Without wasting much of our time, let's get deep into the action. All right, in the introduction and the motivation videos, we've learned about the concept of limits. We've seen that for almost all functions, what we are required to do is to substitute directly. And if that doesn't work, we've seen several techniques that we can try to use. Okay. And also in the last video of the motivation videos, I produced different trigonometric identities that can be of help to us, which is something that would really be helpful for this video. And in this case, if we try direct substitution, we have that this is 1 minus cosine of pi times 0 all over 0 squared. That is the same thing as 1 minus cos 0 over 0. That is 1 minus 1, since the cosine of 0 is 1, over 0. That is 0 over 0, which is an abomination answer. Therefore, we need to think of what to do. The first method, factorization, the second one, rationalization, all of those ones will not work. But we don't want to use L'Hopital's rule. So what do? We invoke the trigonometric identities. So the one that will work here is to multiply by the conjugate of the numerator of the trigonometric function that we have here. So we do times 1 plus cos pi x over 1 plus cos pi x. And what does this give us? This gives us the limit as x tends to 0 of the numerator is a difference of 2 squares. So this is going to be 1 squared minus cos squared of pi x all over x squared into bracket 1 plus cosine of pi x. Now, we know from the Pythagorean identities that sine square theta plus cos square theta equals to 1. That tells us that sine square theta is equal to 1 minus cos square theta. So using this identity, we can see something similar in the numerator here. So we have the limit as x goes to 0 of sine squared of pi x over x squared 1 plus cos pi x. The danger is not averted yet, because if we try to plug in 0 here, we are still going to get sine 0 over 0 times something, and that is 0 over 0. So it means we still need to continue our manipulations. However, it is not hard to see that this is the same thing as the limit as x tends to 0 of sine squared of pi x over x squared times 1 over 1 plus cos pi x. And this is the same thing as the limit. We can break this down. The limit as x tends to 0 of sine pi x over x squared times the limit as x goes to 0 of 1 over 1 plus cosine of pi x. So at this point, the one on the right is settled because it is going to give us something meaningful. The one on the left requires that we remember the fact that we know from the previous video, that the limit as x tends to 0 of sine x over x is equal to 1. This is not exactly sine x over x, but we can see that it is very close to what we have here. So to make it exactly what we have here, the trick that we usually use is to multiply by something that will make both the numerator and the denominator be the same thing. Actually, we know that the limit of f of x squared as x goes to a is equal to the limit as x goes to a of f of x all squared. What does that mean? It means I can actually pull this inside and say this is sine pi x over x squared times the one on this right. I can actually go ahead and do the substitution. This is 1 over 1 plus cos pi times 0. So the one in this bracket here, the trick is, like I said, I want the denominator and what is inside the bracket of the sign to be the same thing. So not only do we have sine x over x equals to 1, we can also have that the limit as x goes to 0 of sine anything, any over any, as long as when x goes to 0, any goes to 0, and sine any goes to 0. This will always be equal to 1. So in this case, I need to multiply. So because I want the denominator to be pi x. So, and I cannot introduce something without making sure that things remain balanced. So if I have pi x and I want pi x in the denominator, I'll say times pi over pi. So we are just multiplying by 1. So nothing changes. This is equal times 1 over 1 plus cosine of 0. And this is equal to the limit as x goes to 0 of sine of pi x over x. Then we have pi here. We have pi here. So this is times 1 over 1 plus 1. And since pi is a constant, this particular one, I can pull it out. So this is pi times the limit as x. Oh, there's a square that I have forgotten. So the limit as x goes to 0 of sine pi x over pi x squared times 1 over 2. So in this case now, this is pi times 1 squared. Why is it pi times 1 squared? Because we already know that the limit of sine any over any as x goes to 0 is equal to 1. And in this case, our any is pi x. So that limit is equal to 1. So we have pi times 1 squared times 1 over 2, which is equal to pi squared over 2. We have successfully avoided the use of L'Hopital's rule, and we have gotten the answer to the limit. So the idea here is to multiply by the conjugate of the trigonometric function that we have there. So we multiply both the numerator and the denominator by 1 plus cosine of pi x, and use the only big identity we use there is the Pythagorean identity. Pythagorean identity, and we also use the basic fact that the limit of sine x over x as x goes to 0 is equal to 1. So that is our first question done. If you have any question, or if there is any comment or reservation about this, be sure to leave it down there in the comment section and I would attend to it. See you in the next video where I move on to the next question.